Yeah, is my voice fine now? I think it should be fine now. Okay, so yeah, this is gonna be a live lecture where I summarize the lectures of your week 3 of your course, Python for Data Science. I did disable. Yeah, so in week 3, we saw some examples of loading data sets, like loading the files and how you handle the files and the missing values, and yeah, how to read columns and how to just see what's in the file and analyze it. So we saw some basic things and like how to do some basic plots and stuff. So yeah, I'll just be going through the same things that was shown in your lectures. Yeah, you can type in your questions in the chat box. Yeah, I will just have a look at those once in a while, and yeah, I'll try to answer your questions. Yeah, so the idea of week 3 is to get you introduced to how you handle data with Python. So it was a simple demonstration with data sets, which were also available on your website. So I've used the same data sets as well. So yeah, let's get started. So we are just importing 2 basic libraries, and yeah, I think 2 more for for making your plots. So yeah, we first load the libraries, and this library is to change your working directory. So yeah, we just run this. I'm also changing my directory to downloads because my data, my samples, I mean, my example files are in this directory. So I changed the directory. So I'm reading, so we saw how to read 3 different types of files. So one is the basic text file, like the .txt files. And and then there's something called comma separated value files, which is like saved with the extension .csv. So this is basically a text file, but instead of each field, so by each field, I mean each column. So all the columns are separated by commas. So that's why it's called comma separated value. So in normal text files, usually these columns are separated by space or tabs. So you could see a tab key on your keyboard. So it's equivalent to 4 spaces. So 4 spaces it's equal to 1 tab. So those are called TSV files, .tsv, tab separated values. So yeah, to read CSV, there are inbuilt functions by the pandas library, which we have imported as PD. So we call that library PD.readCSV is the function. So read CSV, and we're just reading the file name. And now I've read it as data underscore CSV. You could name this as anything you want. And then you just do data underscore CSV dot head. So dot head by default, it prints the first 5 rows and all the columns. So if you want to print first 10 rows, you write 10 in the bracket. So you can see it has printed 10 rows, like 0 to 9, so which are 10 rows. So if you want 20, you can print 20 as well. You can print 20. So if you don't specify anything in here, it's just a default of 5 rows. So this just gives you an overview of what is in the file, and yeah, what are the columns in the files, and like you can see what missing values are there. So if the file has empty values, Python by default, it makes it NaN. But these are some special characters which are also missing values. So those also have to be converted to NaN. So to do that, you first identify the missing values. So here we have seen that these are the missing values. So when you read the CSV, what you do is you specify NA underscore values is equal to, this is a list. So within a list, which is like within square brackets, you specify this 2 question marks, comma, in single or double quotes, you specify this triple hash. So you do that, and you want this column to be your row names. So that's what you call index column. By index column, I want the zeroth column, the column named 0 to be the row names, which is the index. So I specify index column is equal to 0. And now when I look at the CSV, it looks like this. So all this is, it has become the row names here, and the other columns remain as such. So you can see the other columns are there, and now you could see instead of question marks, there's NaN. Instead of this triple hash, there's also NaN. So this is how, like, you identify missing values and you deal with those. At first, you just fill in the missing values and you set your row names. So these were the basic commands, and that's a CSV file. Wait, let me, I don't know if this is, no, I think, I don't know if this has a separator field. Okay, this doesn't have it. Yeah, it'll come in the next few cells. Okay, so the next thing is Excel spreadsheet. So this is just a normal Excel spreadsheet. I can try to open it. Iris data. So for Windows, you can install something called Notepad++. I can type that in here. So in Notepad++, you can open a lot of different file formats. So the .txt extension, you can open with your default Notepad. But when you want to open like other big files, this Notepad++ is very useful, and you can do a lot of functions that Notepad as well. So yeah, this is my .csv file. Oh, I think you can't see it. Yeah, let me reshare my screen. Okay. So this is my .csv file. So in Mac, you have something called you can install something called Sublime Text if you have like a MacBook. And I think for Linux, uh, where is my chat box? What's happening? Okay. So for Windows and Linux, Notepad++, like these are text editors, like just to look at text files. For Mac, Sublime Text. So you can see I'm opening my CSV with Sublime Text. Yeah, so when I open my CSV file, it looks like this. So you can see every column is separated by a comma. So that's why it's called a comma separated file. You can also open your CSV files. Yeah, you can also open your CSV file with Excel. So you have Microsoft Excel. You choose that to open your CSV file. You can still open it. So yeah, here now you can see your Iris data sample CSV file is open. So here Excel by default, it either asks what you want your field separators to be. So in that case, you select delimiter as a comma, and then you'll get each separate column like this. So yeah, that's one thing. And now we have our Excel file, which is basically the same data set. And now we want to import this to Python. So how do we do that? So to do that, yeah. So to do that, Python has, again, Pandas has an inbuilt function called read_Excel. So you just specify the name of your Excel and the sheet of your Excel file, the sheet that you want to read. So you can see the name of the sheet is iris_data. So that's why you specify iris_data as sheet name. So by default, this sheet name is just like sheet 1, sheet 2. So whatever the sheet name is, you have to specify it. So now I've changed the sheet name. If I open this, you'll get an error because I've specified the wrong sheet name. It says worksheet named iris data not found. So I have tried sheet 1 because I just renamed it, right? So yeah, when I open sheet 1, you get your data displayed here. And even here the same thing, like to convert NAs and this NA values, you have to specify these. And yeah, you can do the same thing like you did with CSVs. And then the next thing is text files, .txt files. Yeah. So here I try to read it. So it's read using a function called read underscore table. And you remember we did dot head. What that does is it displays the first 5 rows. So dot tail, what it does is it displays the last 5 rows. So if you want to display the last 10 rows, again, you just specify a number here, right? So I just want 7 rows, so I'm doing that. So now you can see what's happening here is all the columns are just recognized as a single column. So that's why everything is displayed like this. So it's just everything is taken as a single column. So what you need to do here is you need to specify a separator or a delimiter. It's called, I think, yeah, delimiter or a separator. You can specify delimiter is equal to or separator is equal to. So here it is separated by spaces. So by default, what it does is it's looking for comma separated files because there's no commas, there's just space. It is not recognizing space. So we need to tell the Python function to recognize the space as a column separator. So we just give a space inside double quotes. And now when you read the file, you can see like different columns are here. Sorry. Yeah. Rupam, yeah, to install any library, you just do pip install library name, like pip install Cbond should work. So you can do this on your terminal, like you go to your terminal, or I don't know how it works in Spider. So within Jupyter, when you want to install, like when you're inside this Jupyter notebook, let's say, and I want to install a package, sometimes pip install this command doesn't work. Pip install cbond doesn't work. You just have to put an exclamatory mark followed by pip install package name, like whatever package name, right? You have to put an exclamatory mark. Small pip. It's not capital. It's just yeah. So that's how things are installed. So delimiter is basically the character that is used to separate columns, right? If there's a comma, like in case of CSV files, each column value is separated by a comma. So in that case, comma is the delimiter or comma is the separator. So in normal text files, usually space is your delimiter. Delimiter means just the character that separates the columns. So that's what you mean here. So here when you specify the correct, if you specify the wrong delimiter, it just takes all the columns as a single column. It doesn't know to recognize the non-default characters as the separators. So when you actually specify the correct thing, it knows and then it does that. Row count in head starts with 0. No, so head is like 1, 2, 3, 4. When I write head 5, it displays first 5 rows, 1, 2, 3, 4, 5. But in Python, it's indexed 0, 1, 2, 3. So yeah, everything starts with 0. So 0, 1, 2, 3, 4. But when you count this, it's 1, 2, 3, 5 rows are here. But the index of the rows starts from 0. That's why like you get 0 to 4. But yeah, that's 5 rows. We have seen tail command is the last rows. We have seen how to read text file. We have seen delimiter. My laptop is hanging. Yeah. So pandas is basically the library that's used to deal with such data. So this structure that you see here, it's called a data frame. So like, yeah, anything of the format columns and rows, like in a tabular format, it's called a data frame. And yeah, whenever you read any file with pd dot, by default, the data type, like, I mean, the format of that object is a data frame. So here again, I'm reading another example data set that was already provided. So it's some car data. It's some data about some cars. So Toyota.csv, I'm reading the same thing. And I'm specifying the index column 0. And yeah, I'm just like looking at what's in the data set. So all this is there. Now I'm just like in this example, we're just modifying these objects, right? To demonstrate to you several things, we're modifying objects, but we also want to keep the original object. So when you want to read the original thing again, you can just read this file from scratch, or what you can do is you can actually copy this object here. So this is how you do it. Object 2 is equal to like object 1, the copy of object 1. Object 1 is equal to cars, which is the original object, dot copy deep is equal to true. By deep is equal to true, what happens is when I modify this cars, when I modify the when I modify this copy cars 1, the original object will be unmodified. So it will remain like however it was when I read it. So that's why I specify deep is equal to true. But even if you don't specify this, by default, I think it takes a true value. So yeah, you can just do cars dot copy as well. So yeah, I'm just keeping a copy of it so that I can work on it later to demonstrate other things to you. So now I want to know what are the columns that is in the car data set. So those are called attributes of a data frame. So attributes are basically what are the components of a data frame. So yeah, we have columns. That's the major thing. We are reading the columns. So I'm just doing cars one dot columns. So that will tell me the name of all the columns that is in your data frame. So we have price of the car, age of the car, like how old the car is, how many kilometers has the car been through, then fuel type and color, HP, horsepower, and yeah, other such features of the car. So one more thing is the size of the data frame. You just do dot size. It gives you the size of the data frame in bytes. So this is basically like 1.4 kilobytes, this object. And then shape of the object. By shape, you like if you do dot shape, you'll get how many rows the data frame has. So it has 1436 rows and it has 10 columns. So we saw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has 10 columns and rows. So it's always rows, comma, columns. That's the shape. So now you want to access a particular value in a particular row or a particular column. So let's say I want to know what is in the 6th row, like index, the row which has the index 6, like 0, 1, 2, 3, 4, 5, 6. I want to see what's at that row, but in age column. So what is there? So to do that, I use this at function, cars.at, square brackets, the row index, comma, your column name. The column index is the names here. So each column has a name, so that is your column index. So row index, comma, column index. So I do that, and you can see 27, there's 27. Let us just see that now. So if you look at this, at index 6, at age column, there's 27, right? So you can fetch that out. That's what we just did using at function. At. And if, yeah, so if you don't know the column name, but you just want to see what is in the 0th column, which is the first column. You want to see what's at the 3rd index, what is at the first column, the 0th index. So that is index at cars dot I at 3, comma 0. So it gives you 3rd index and 0th column is price. So the value here is 14950, right? So let's see if we get that. Cars dot I at 3, comma 0, we get 14950. We get the same thing. So that's how you just locate things. And now what you want to do is you want to print multiple rows of one particular column. So you do that with lock, LOC, cars.lock. So here we specify the rows that we want to display. So I am just doing 0 to 7. So if I specify nothing, it starts from whatever the first value is. So it starts from 0th index. So if I do 5 to 7, or let's say I just do 2 to 7 and fuel type, I want fuel type column. See, it prints second index to seventh index. If I just print colon 7, it prints 0 to 7, right? If you don't specify anything here, and if you start with, let's say, 1000, there are 1436. Let's say I specify 1430. So what this will do is it will print the last 6 rows. So 1430 to the total number of rows is, oh, sorry, the 60 here. Uh, no, sorry. Oh, yeah, 1436. So I do 1430. If I don't specify an endpoint, it just prints till the last row. So you see, till your last row is being printed. So that's how you access multiple rows or columns. Yeah, fuel type, and you can access any column by specifying the column name here using lock function. And now you want to see what all data types are there in the object, like in the data frame. So by data types, we mean like a character, integer, float, object. Yeah, so you just want to see which are the numerical data types and which are the categorical data types, because they might have to be handled differently. Like when you perform some function on some categorical function on a numerical, it may not work, and it could be otherwise. So you just want to know what are the data types. So for that, you do cars1.d types. So we can see price column is of data type integer 4. Age is of float. Kilometers is an object. So object is similar to a character data type, like a character data type, but it just takes up more space. So that's one big difference between object and character. So if you have a data frame, let's say you have loaded a very huge data frame, it takes up so much space because all of these are objects. If you just convert all these objects to simply characters, that will reduce the space that your data frame takes. So yeah, these are just the different data types, and you could see that using this function. And now you want to see how many columns are of each of the data types. So for that, the function that was given in your tutorial was get, like df data frame dot get underscore d type underscore counts. But for some cases, you might have, if you have tried, it might not have worked, because like Python and all the libraries in Python, they are constantly being updated. So there are different, like if you have noticed, there are different versions of Python, like 3.8, 3.6, 3.9. Similarly, even for each library, there are different versions, like 1.6.2. So there are different such versions. So in every version, they keep updating things so that it has better performance and it uses less memory, and for several reasons, they keep updating. So when they update, what happens is they might write a function differently. So when they write a function differently, the old functions, when you call it, it'll throw an error. So that's why for some of you, you might have gotten an error when you run this get underscore data type dot counts, because this function would have been depreciated. By depreciated, you mean it is not used anymore. In the newer versions, it's not used. So instead of that, you just use cars1 dot d types dot value dot counts. I'll paste that here. So if this df gives error, try the below function. Try df dot. So if you try this, it should work. So basically, like both of these, they do the same thing, but just in newer versions of Pythons and the corresponding libraries, the given command, older command doesn't work. It throws error. So instead, if you try this, it will give you output. So it will tell you, so there are 4 columns with int 64 value. So if you look at this, you can verify it. So there's one int 64 here, 1, 2, 2, 3, and 4, right? So there's 4 int 64. And similarly, 1, 2, 3, 4 objects. 4 objects. Float 64, there are 2. 1 float 64, 2 float 64. So that's what this thing summarizes. It summarizes how many columns are of each data type. So yeah, if you faced an error, just try it with the command that I've pasted here. It should work. Okay, so now I want to subset my data frame. By subset, I mean I just want to choose specific columns of interest or specific rows, anything like specific things of interest. So in this case, I just want to keep numerical data. I'm excluding all the object or the character data types. So I'm doing cars df dot select d types, select underscore d types. In the bracket, I'm excluding object. So I'm excluding object. You can see all the object columns, which is kilometer, fuel type, HP, and doors. So they are not here in this data frame. All these are excluded. So let's say I do exclude float 64. If I exclude that, what did I do? Uh, oh, is this not? Okay, so I've excluded float 64. What were the float? Age and met color were float values. So you can see those columns are not here, right? So this way you can exclude whatever things you want. So if you get an error while doing something, you just try multiple things like you put it inside quotes, or you might have missed brackets. So yeah, these are some things that you try when you get an error. Or simple thing is you just copy paste that error on Google. Somebody must have. So this is website called Stack Overflow. So yeah, that's where most of the solutions are. Okay, so we now selected data types. Now you just want to see the summary of the data frame. So you just want to get information of the data frame. You just do df.info. So what that gives is it tells you it's like a pandas core data frame. It has this many values. The index ranges from 0 to this. And data columns, it has 10 columns. It tells you like the column information, like what data type it is. It gives you all such information, data types, memory usage. So this just gives a summary of everything. So we just individually saw each and everything. We saw shape, we saw size, we saw data types, value counts. So instead of that, if we do info, it will just give the whole summary of that. See here itself, it gives float. There are 2 columns of float 64, 4 columns of this, and so on. And now this each column, you want to see what are the unique values in each column. So to do that, we use NumPy library, NP. So you do NP dot unique within the bracket the name of your data frame and the name of the column. So I want to see what are the values in doors column. So the in doors column, the values are 2, 3, 4, 5 and numbers 4, 3, 5. So when it's like this, you don't want these, right? You just want it to be consistent so that when you analyze the data, let's say I want to filter all the rows where the number of doors is equal to 2. Let's say I want to filter the number of doors is equal to 3. So I give numerical 3. So when I do that, it will only pick the rows that have this 3, right? It'll exclude this. So which means you're losing information. So this is
Hello,
also 3. Just because it's of a different
hello,
uh, just because it's of a different format, yeah, that gets
hello.
excluded. Yes. Is somebody saying something? Yeah, if you have any
Sorry,
questions, just
sorry. No, no, no. Continue.
yep. All right. So I was saying you want the values to be consistent. So this 3 is the same, this 3 is also the same. There's just because they're represented in different ways, like there's some discrepancy. So what you want to do in this case is you want to replace these. You want to replace this FIVE with number 5, 4 with number 4, 3 with number 3. So to do that, you can use the replace function. So yeah, this is the syntax. So data frame. So what column that value is? So the column name dot replace. So you want to replace 3 to number 3. In place is equal to true means it will just overwrite. So instead of 3, it will replace it with 3. So you're doing that. Like within replace. So it's basically the source. The source is 3, THRE, and then what you want to replace it with, destination value, and then in place is equal to true. Yeah, that's the syntax. You run this, and then now you see, unique cars. Doors, it's just like one of the columns in the data frame, right? You see the data frame, there are doors. Doors just means, I don't know, like how many doors are there in the car, or how many doors are working, like how many functional doors. Yeah, it could mean like 4 normal doors and the trunk door. Maybe that's why there are 5 doors that you see here. Yeah, that's just something here. So now we have replaced it, and you see unique, there are 2, 3, 4, 5. So now because we converted this just so that all the values are consistent. So when you do this, it's still probably of a character data type or something. So you just, so that everything's consistent, you do as type int. You just make all the values in that column as integer. You do that. And then now you see unique, you see 2, 3, 4, 5. So it's fine. There's no 5, 4, 3. These are not here in this command because we have replaced these with 3, 4, and 5. So that's why now you get just the numbers. Okay. What is converting data types? Yeah, so like in your first lecture itself, you would have seen how you convert from a object to integer, or like an integer to a string, like wherever it's possible. You just do as type, like cars one automatic, you want to convert it to object. So as type object. Yeah, so this is all fine. We don't need these. So what is this? So what are we doing here is, we earlier saw that there are a lot of missing values in your data set, right? So you need, like before you start doing any analysis, you need to know how many missing values are there in each column. So that's what you're trying to do here. Cars dot is null. Like you're asking if it's null. And what is the sum of the null? Null means missing values. So here from this, it says price, it doesn't have any missing values. Age column, it has 100 missing values. Kilometer has 0. Yeah, everything has 0 except fuel type has 100 missing values. Met color, it has 150 missing values. So these are a lot of missing values, right? You need to, if there are just like 2, 3 missing values, it's fine. Like you have 1,400 values. Out of them, if 2 values are missing, it's still fine. It won't affect your analysis or your results. But when there are like 350 missing values here, so that is like a significant number. So in this case, what you do is you have to handle these missing values. You have to impute missing values. By imputation, you mean you just fill in the missing values with the closest values. That makes sense. So you might have seen extrapolation. Why double hashtag was used, single why not used? It's because that data set, it has only double hashtag missing values. So here it has 4 question marks. So that's why I'm using 4 question marks as a missing value. So you just need to see what is in your data. If your data set has missing value, like NA value as a hashtag, then you specify 1 hash. It depends on what is here. So that's why, yeah, like when you read a thing, you specify NA values, right? You do triple hash here. If you have just a missing value with a single hashtag, you specify single hash here. It all depends on what is there in your data. So what did we do? Converting. Yeah. So when we have these 350 missing values, we want to impute it. So you might have seen extrapolation, interpolation, and all, right? So you are fitting a line. So you know like what is going to be the rest of the value. So you just fit the line and you can find what all the missing point is by just considering the data points surrounding it. So we use a similar concept here. So it's basically we do two things. Like we do either of the two things. So when your missing value is numerical, any numerical data type, if it's an integer or a float, if it's any such numerical data type, like let's say age. Age is a number, right? Price is also a number. So when age value is missing, like any such numerical data is missing, what you do is you either fill it in with the mean value, mean which is average, or you fill in using the median value. Median is the value which is represented the most number of times. That is your median. So you do this in case of numerical data types. If you have categorical values, let's say like we had, there's no category, where is it? Oh, sorry, this is just count here. Okay, wait, let me look at cars again. Okay, we have fuel type. So this is categorical. So when you do fuel type, what you do is you just fill in the value. By value, I mean the categorical value that has been represented the most number of times. Okay, so when you do data frame, just a second. Hmm. Oh, sorry. Yeah. I said the definition for mode. So mode is the value that is represented the most number of times. Median is the like middle, like when you construct a, it's more or less the same thing. So let's say you consider a density plot. You just, yeah, let's say you do a density plot. So you arrange the values based on lowest to highest represented numbers. So you let's say you get a bell curve, and median is basically a middle value. That is the definition of median. So in this case, in our case, the middle value is the value that is represented the most times. That's why I just like interchanged the term. So by definition, median means the middle value. But in our case, like by middle value, we mean we order it based on the frequency of each observation. So in that case, like it's a bell curve, and yeah, the median value, the middle value becomes a value that's most occurred. Okay, so now I'm just doing cars2.describe. It gives a summary of each of the column. So it tells you how many values are there in the count. It gives you the mean value, which is the average. It gives standard deviation. It tells you the minimum value. It tells you the maximum value. And it tells you like what's 25% of the value and all that. So we don't need all this information. We just need median, we need mean. Yeah, we just need mean and median for this specific purpose. So now we are, I think, yeah. So age, fuel type, met color. So these three columns had missing values. So let's first look at age. So age is a numerical value. So this is your mean age. The average age of the car is 55.6. So if you look at the median age, it is 59. So what you do mostly is you mostly go with the mean. Like you look at the mean and medium and decide which to go with. So if 55 and 59, they are very close values. So it won't make much difference. But still you go for the lesser value because we are imputing the values. We don't want to over emphasize anything here. So because mean is smallest compared to this, you go with mean. You impute all the missing values in age column with mean. So we are just doing cars to age dot fill NA. So we are filling the missing values of car to age with cars to age mean. So that's what we're doing. In place true. So we did that. And same thing. So now we are checking kilometers, mean and median. Kilometer mean. How this will work. Okay, so the mean kilometer is 68594. Median is 63634. So this is a big difference, right? It's almost 5,000. Oh, no, wait, one. Yeah, it's like this is 68,594. This is 63,634. So it's almost 5,000 kilometers different. So that's a big difference. So when there's a big difference, again you go for which is the smallest value. Mean is bigger, median is smaller. So you're filling it with median. So which has the smaller value, you're filling it with. So cars to kilometer, fill NA cars to kilometer, median in place true. So you're filling that. We are doing the same thing for horsepower. We are seeing which horsepower is yeah 101, 110, not much difference, but still we are going for the smallest value. So mean is smaller here. Mean is smaller here, so we're filling all HP with mean. We did that. Now again you're looking at what are the missing values. Oh, this is because I already replaced it. Yeah, I'm sorry about that. So yeah, if you remember, so far we just if imputed the missing values of age, kilometer, HP, and yeah, age, kilometer, and HP. So there was fuel type also that was missing. If you look at this, fuel type was missing. So let's see fuel type. So fuel type, if you remember, is a categorical. It has petrol, diesel, and CNG. So in terms of categorical values, what you do is you fill in the missing values with the value that is present in most numbers. So to find the number each value is represented, you do dot value counts. And it already orders it from biggest to smallest, descending, like ascending or no, descending order, like biggest to smallest. So it says petrol is the maximum represented. So this is index 0, right? This is index 0, this is index 1, now this is index 2. So petrol, you want to fill all the missing values with petrol. So that's what you're doing here. You're doing fill NA, cars to fuel type, dot value counts, dot in index 0 would be your first value, which is petrol. See? No, but, oh, sorry. Dot index 0 is petrol. So this is what you want to fill it with. So that's why you're doing car fill fuel type, fill NA, cars to fuel type val counts, index 0. So that's what you're filling it with. So now this is how you deal with numerical and categorical. So if it's numerical, you compare the mean and median, and whichever number is smallest, you fill in the missing values with that value. And for excuse me. Yeah, and for categorical values, you fill in the values that's most represented. So that you find out using value counts and you choose the index 0. That is the first one. So now we have dealt with missing values. So now in our case, we only had 10 columns. So it was easy for us to manually look at each column and fill in the missing Yeah, it was easier for us to fill in, like look, inspect every column and fill in the missing observations. But let's say you have 50 to 100 columns now. If you have that, you can't individually sit and look at 100 columns, right? So in that case, you just do a lambda function. So this is how you write it. So we already know that we we are going for numerical values, we're either filling mean or median. So, but when there are like such large number of observations, we usually go with the mean. So we are filling all the numerical values with the mean, and we are filling all the missing categorical values with value counts index 0. So we're writing the function here. So this I had just taken another copy of the data frame. So I'm using apply. I'm applying a lambda function. So this is just the syntax. So what lambda function does is it does this thing. So the function is basically fill NA, X is your data frame, like your column. So column dot mean if data type is equal to float. Else, if it's not a float, what it does is it fills all your missing values with value dot counts dot index 0. So I'm applying this to all the columns. So wherever there's missing, it will do that. So now you can see it has already done it and you have no missing types. So you just need to remember the syntax of this, that there's no other like shortcut for that. You have to remember the syntaxes. Yeah, so that's how you deal with missing values. And now let's see how to write loops. So the loops are basically called control structures. Just a second. Uh, Importing. I think you have specified a space after read, Piyush. Yeah. And you have to close your quotations. That's one thing. And there should be no space between read and underscore. Second, everyone. Yeah. If you try with this, it should work. And you have to like import, before that you have to import pandas as PD. Only then your PD, that function will work. So the next thing is control structures, which is basically loops. What are we doing here? Okay. So now what we're doing is we are categorizing each row based on the price. So we are looping through price column and we are splitting it as 3 categories: low price, medium price, and high price. So I'm using like multiple like control structures here. I'm using a for loop and I'm also using an if else loop here. So for I in the range, length of cars of price. So length of cars of price would be the total number of rows. So length of cars of price would be 1436. So it will go from index 0 to 1436, or like whatever the length, whatever the last value of uh, the data frame index is, it will loop until that. So that's why you just do length, because you don't know, like you might read several data frames from different sources. You might not know what is how many rows each data frame has. So in that case, to automate it, you're just specifying length of cars of price. So it'll always take in the last thing. So for basically loops through it reads every value. So for I in range, the thing. So yeah, it'll go to 1435. So it'll go from index 0 to 1435. So now it loops through every value. And now if cars1 dot price of I is lesser than or equal to 8450, we are adding a new column called price underscore class. So we're doing that price class is equal to low. We are creating a new column and we are filling in the values of the new column. It is low if price is less than this value. L, or if it is greater than, if car's price is greater than 8450, no, sorry, else if it's between, if it's between 8450 and lesser than or equal to 11,950, we are filling price class with medium. Else, so else what it does is it just fills in high for the values that do not meet both these conditions. So we specified for lesser than, we also specified between this range, and there's nothing specified for the upper limit, like higher range. Like for everything above 11,950, it gets filled with high. So this is what the rule loop does. And when you do that and you look at cars, you can see a new column called price class. So you can see first one like 13,500. So this is above 11,000, right? So that's why it's high. Now look at this, it's 7,500. 7,500 is less than or equal to 8,450. That's why it's low. And this 10,800, it's in between these two values. So that's why it's medium. So yeah, this is just like when you want to add new columns based on the information using the existing columns, you use such loop structures. And you can do the same thing using a while loop. So here we used a for loop. Instead of that, you can use a while loop. It's just the syntax different, but the concept here is the same. Yeah, there's no way you will have to remember how this is written. So it just has like, you need to remember the first line and you need to remember the format of all this. But all these values, it depends on what data you have and what data you want. So yeah, there's no shortcut to that. You have to remember. And now you want to see how many cars are medium price, how many cars are low, how many are high price. So you do similar value counts. You can see that most of the cars, like 751 cars, they are in the medium price range. So yeah, that's one thing. And so all these things that we do, so we use all these inbuilt functions, right? We use something. So this, for example, is an inbuilt function. Is null sum. So sum itself is a function. So sum, what is it basically? It's just value 1 plus value 2 plus value 3, like whatever value we have, it is just an addition of everything. So how are all these functions defined? So in most cases, we will not have inbuilt functions for all scenarios. So these inbuilt functions are built only for basic operations like sum, mean, median. So all these operations are like basic. It's not that only I am going to use that function only I want. It's something that everybody uses. That's why these libraries have such inbuilt functions. But I want to do operations based on my data set and based on my analysis and application. So I can define my own functions as well. So this is how you write functions. So you just define a function called convert underscore age. This is basically the name of your function. You can name this like whatever you want. So you're defining a function called convert age. Inside the brackets, you have to specify the input value. Like whatever input you want inside the function, that is what you write here. And colon. So in your next line. So there's something called indentation in Python. So by indentation, you mean the spacing. The spacing is called indentation. So when you write all these loops, you can see this gap, right? You can see this gap. So if you don't write this gap, you'll get an error. See, so it'll say unindent does not match outer indentation. It's like you'll give indentation error. So it has to be follow this certain indentations. Like for loops, so what is this indentation thing? It has to be 4 spaces. So you have written the while loop first line. Your second line, your if statement should start after 4 spaces. So you can see there's 1 space, 2 space, 3 space, 4 spaces. Or if you can see the tab key in your keyboard, you just do tab. Tab is equal to 4 spaces. So either you, like when you do indentation, you use a tab key or a 4 spaces. So we saw that's called indentation. Yeah, it's same thing. So even when you define functions, your first line and then second and all the other lines has to follow the spacing. So now you're naming your function and you're specifying what input your function takes. And then in the next line or lines, it has to be what your function actually does. So what we are doing here is we are converting the age in months to years. So 12 months is equal to 1 year. So I'm converting months to years. So you just divide by 12 here. So output that we want is age in years is equal to age in months divided by 12. And then return age in years. So within the function, we have created this thing called age in years. And I want my output to be age in years. So that's why I'm writing return age in years. So if I just run this, my function is called. It's not called yet. The function is defined. So once I just run this function separately, I can simply use this. So let's say I'm creating a new column called cars1 age converted is equal to. Now I'm applying the convert age function. So the input that it needs is age in months. So age in months is basically your age column of your data frame. So cars1 age, you just do dot apply and the name of your function. You do that. This function will be applied and all the new values will be saved to your column. Now I'm running that and I'm just outputting the age converted. And then age, I'm outputting. So I can see age in months was 23 months. 23 months is almost like 2 years, right? So you have converted to years, it's 1.9 years. Same like 30 months is some like 2.5 years. So 2.5 years. So you can see that it is converted. So that's how you write a simple function. So here we have written this function to use only one column. You can also write it such that it can work with multiple columns. So I'm defining a function called convert. The input it takes is age and kilometer. So I'm writing age converted is equal to age by 12. Kilometer also it's doing kilometer per month. You're trying to see for each year how much kilometer has the car run for every year. So it's just doing kilometer divided by age, where age is your years. So now I want to return both age converted and kilometer per month. So I'm writing return and within a list, I'm writing what all outputs I want to return. So you do the same thing. You write it within a lambda function because there are multiple, what is this, multiple columns. So I want to create two new columns, cars1 age converted and cars1 kilometer per month. So yeah, this is the format. You have to write it within a zip. And then cars1 dot apply. We're applying lambda function for x. X is basically your columns. And then you're applying C convert for x of age. Like by x of age, you mean every single value of age. And then every single value of kilometer. So yeah, it does that. Okay, I just got an error because I had to, yeah, before that I just convert my values to numerical format. So I'm converting the age and kilometers to numeric. So pandas to numeric, converting it to numeric format, and then I'm running the function. And you can see two columns are added. So age 23 months is like 1.9 years, and kilometer per month it basically does 46,986 divided by 1.9. So it gives you this. So yeah, that's how you write functions and you use those functions. Okay, so there were other more analysis that were done. So basically like how like it covered topics of probability. I might need my pen here. Okay, so like so there's a function. So when you want to do probability related operations, that's when you use this. So whatever I'm teaching here, it might not be applicable to every situation. So we're just telling like what all functions are there so that later when you think about you want to do something, you can remember that I can apply this function. I can use this to do this. So like, yeah, with that said, so to do any probability analysis, you can do it using the following functions. So there's something called cross tab. So it just tells you like, let's say I'm doing PD dot cross tab, and the value to which I'm doing cross tab is cars fuel type. So I'm using that column. And what I want to do, I want to count. I want to see the unique values in this column, and I want to see how many values, like how many times each value occurs. So that's what you mean by count here. And I'm dropping the NA values, like I'm not counting the missing values. But already we have imputed everything, so that should not be a problem. Like after you impute, that should not matter here. But yeah, so what this crosstab does is it tells you what are the values in fuel type and how many individual values are there. So there are 15 CNG fuel types, like 15 cars with CNG fuel type, 144 cars with diesel fuel type, 1177 cars with petrol fuel type. So now this is like a one-way table. You're just counting the values in one column. You can also use multiple columns. So I'm creating a like 2x4 table. So fuel type is given here. Fuel type is petrol, diesel, and that the counts, and automatic 0 or 1. By 0, you mean the car is not automatic, it's a manual car. By 1, you mean that it is automatic. So by this table, what you can say is that there are 15 cars with manual, and there are 144 cars of manual mode, and there are 11,004 petrol cars manual. There are 0 CNG and diesel automatic cars, but there are 73 automatic petrol cars. So that's what you get out of this table. Like you want to see the relationship between two columns, like how many automatic petrol cars are there. So yeah, that just gives you the count of that. And now this is something called a frequency table. So to get a frequency table, you just add this parameter normalize is equal to true. So now what do I mean by frequency table? So frequency table, so you have this table already. So now if you add 15 plus 144 plus 1104 plus 73, you'll get some value, right? So what frequency table means? It does 15 divided by that specific value and gives you this value. So 15 divided by total, and this is 144 divided by total. This is 1104 divided by total. This is 73 divided by total. So if you want, I can just like quickly, just a second. Yeah, I can just show that here. Yeah, so the total value is 1336. So if I add everything, I get 1336, right? So what is 15 by 1336? Let's say I assign this as total. 15 divided by total. It gives me 0.0112. So that's what this value is, right? And if I do 73 divided by total, it gives 0.05. So this is how this frequency table is computed. If you do normalize equal to, it gives a frequency table. That's how it is computed. It is the actual value divided by total value, all the occurrences. Yeah. Okay, now we have seen a frequency table, and then you compute something called a marginal probability. Okay. So to do compute marginal probability, you do normalize is equal to true, which computes your frequency table. And in addition to that, you do use margins is equal to true. So what that does is it gives this particular table. So what information this tells you is that the probability, oh no, it's not that. Hmm. No, yeah, margins, it just gives you the sum of all these. So the sum of this plus this would give you a specific value. So this is the value, right? And it gives you a column sum as well. Like 0 plus this is this value. So marginal probability means it just like sums up these. And what this means that 0.9 is the probability that the car is CNG or diesel or petrol, right? And this 0.0122 is the probability that a CNG car is either zero, like manual or automatic. So yeah, that's how you read this table. And this is the probability that uh, the automatic car is either CNG or diesel or petrol. This is it. And the next thing is conditional probability. So it's a probability uh, of an event A given that the another event has already occurred. So let's say we already know that automatic event. So given that the car is manual, what is the probability that the car has CNG fuel? Given that the car is manual, what is the probability that the car has petrol? So that this is how you read this table. So the probability of a car being petrol with a manual is 0.8. Given that the car is a manual is 0.8. The probability that the car is petrol, given that the car is automatic, is 100% probability, because we saw that all the cars that are automatic are all petrol, right? So this also it's in line with that. Where is it? Yeah, it's here. So how this is computed? How this is computed is that how many cars? 15 plus 144 plus 1104. So we had 15 plus 144 plus 1104, right? So it just takes the sum of these. It does not take into account the sum of this 73. So excluding that, so manual sum is equal to 15 plus 144 plus 1104. Auto, we already know there are 73 automatic cars. Okay, we have done that. So we know there are 15 CNGs. So 15 divided by, given that it is manual, we want to know. divided by manual. So we get 0.0118. So that is this value. That's how this is computed. So now I want to compute petrol, the probability that the car is petrol. So total number of cars with petrol divided by, which is basically the probability that the car has petrol given that the car is automatic. So how many cars are automatic? So given 73 cars were automatic. So I just divided by automatic, I'll get 15. No, 73. I'm doing something wrong. Oh, yeah. So the number of, there are 101,104 petrol cars, given that they are zero manual mode is 0.87. So that this is what conditional probability is, and that's how this is computed. So yeah, you just need to know that to do like instead of sitting and calculating everything, you just write this one command, you'll get the output. You don't have to manually compute everything. You just need to know how to read these tables. So the next thing is correlation. Correlation is, it basically tells you the strength of association or relationship between two variables. So like here in this example, we are looking at the correlation between age and kilometer. So it makes sense that uh, an older car would have run more kilometers, right? So that's what we try to like see the relationship. We also see age and price. So as the age of the car, when I'm trying to sell a car, if it's an old car, the price I have to sell it for lesser price. If it's a new car, the price is high. So we can see that this is inversely correlated. Age and price is inversely correlated. By inversely correlated, you see a negative trend. So as age increases, price decreases. I can also do the same for age and kilometers. So here we could see a positive correlation. We could see like as the age increases, kilometer also increases. So if you think about it logically, it also makes sense. So to see such associations, you can visualize it. So it's impossible to see each and every, like you can't look at every single value, right? So instead of that, if you just use these plots to represent, it's much easier. You use a scatter plot. So you use a matplotlib. So import matplotlib.pyplot as plt. So plt.scatter x comma y. So you want age in your x-axis and price in your y-axis. So that's what you do here. X comma y. So similarly, we are just showing that we can do multiple different kinds of plots. We can do a histogram. Histogram is something like that looks like this. So this is how you do it. You just do plot.hist and you want this, like you want to plot kilometers and you want to color your borders. So that's why you're specifying edge color black. So if I specify edge color red, you can see that everything is red here. So here we're doing something called a bar plot. So we are seeing, we are plotting fuel type and we're plotting its value counts. So fuel counts is equal to cars fuel type dot value counts. So we saw there are 1,100 petrol, some 70, like 100 diesel and 15 CNG. So that's what we're trying to plot here. So we're just doing plot dot bar fuel counts dot index x comma y. So by fuel counts dot index, we mean petrol, the values. So which is petrol, diesel, and this. And we are on y-axis, we are plotting the fuel counts, the values. So we can also be, like add aesthetics to the plot. So we are adding a title. So after calling the main plot, you do plot dot title, bar plot of fuel type. You get this. And you can also add x-axis and y-axis labels. To add x-axis labels, you do this. Plot dot x label fuel type, plot dot y label of frequency. And so this axis value, you're rotating the labels to 45 degrees. So x ticks, you're rotating to 45 degrees. So if you do it 90 degrees, what happens? You can see that it becomes 90 degrees. If you don't do anything, it looks like this. So this is how you make the plot look better. You can also specify different colors for each bar by like just specifying a color palette. And inside your plot dot bar function, you add colors is equal to colors length of fuel counts. We have 3 fuel counts, so we're just using blue, green, and red. So that's what this is done. And yeah, Seaborn is another package similar to Matplotlib to make plots. So this is the Seaborn. SNS dot scatter plot is basically LM plot. So you specify X, Y, and data is your data frame. So data frame is cars 1. Yeah. So you can add a regression line. So by default, it adds a regression line. You can also do it without a regression line. So to do without regression line, you just use Seaborn dot scatter plot. So if you want a regression line, you do LM plot. So it does a scatter plot with a regression line. Even here, you can specify colors. Color blue, the size of each dot. If I make the size 50, it becomes smaller. Or I just make 10, it becomes very small. Yeah, you can adjust all this. Alpha is basically the transparency. Let me make it a bit bigger. I'll make it 40. This is 0.7. If I make it 0.2, you can see that the points are very transparent. So alpha is basically the transparency. So 100% alpha means it's opaque. It's solid color. So if you reduce the transparency value, it becomes more transparent. Alpha value. And yeah, you can also like specify each category with different colors. So by that you specify hue is equal to, I want to color the points based on fuel type. I have only plotted age and price, like age versus price, but I want to color each point based on fuel type. You can also do that by specifying hue is equal to fuel type column. Yeah, in the same way you can plot histogram, box plots. Yeah, so these are bar plots. You can also do grouped bar plots. So you have done one category, like one column versus their counts, right? You can also do multiple columns, like fuel type. No, you're grouping each fuel type into based on this automatic column as well. So this is called a grouped bar plot. Since like if you remember, there was 0 diesel and 0 CNG cars that were automatic, you don't have any bar here. Because petrol had both manual and automatic, you see 2 bars here. So if this had value, this would also have multiple bars. So this is called a grouped bar plot. And this is called a box plot. Even box plot, you can do the same thing. You can do a grouped box plot that looks like this. So box plot is basically used when you want to look at the distribution of something. So when you do this, the box is contained where most of the points lie. So by this is actually the mean line. So you can see most of your values, they lie in this range. Price, right? Most of the petrol cars, they're lying between 1,000, this is 10,000. They're lying between 8,000 and something around 13,000. So many cars are lying between this range. While there are very few petrol cars that are above like 20,000, like above 16,000. So these are outliers, which are the extreme values. So those are represented as like outlier points. So this is your minimum limit, and this is your maximum. And like these are just outliers, which are extreme values. So that's how you read. So this is useful when you want to look at the distribution of something. And when you want to look at multiple plots, you just do pairwise. So you have price, age. So you want to do one column versus another. So this plot basically gives you price versus price. So this is your x-axis has all the columns, price, age, color, automatic, and all that. Your y-axis also has price, age, automatic, met color. So if you look at this, it gives you price versus price is in y-axis, age is in x-axis. So instead of just doing like these scatter plots separately, this one gives you an overall picture. If I want to look at weight versus cc, I just like age versus cc, I just look at this plot. Age is in x-axis, cc is in y-axis. And here, yeah. So this function is just to look at all pairwise combinations together. SNS pair plot. Yeah, one of the question was seventh problem. Week 3, right? Week 3, 7. Yeah, sorry if you couldn't understand anything. So yeah, I know this is like a lot of information. Just listening to the lecture will not help at all. It'll just be like I'm just blabbering something, and yeah, you wouldn't know what to do with all this information. So this is all useful only when you sit with it and try to practice and like maybe take your own Excel file and try to analyze it. So like as you practice, you'll get an idea of why we are doing this and all that. So just listening to this is not gonna help. Uh, yeah, I'm trying to look at the assignment, but yeah. The week, question number 7, is it which of the following countries have maximum locations for cocoa manufacturing companies? Cocoa percent. So I think you should be given a data set. There should be a data set. Let me check. Mm, cocoa percent. So yeah, if you look at question number 5, there's a link to flavors of cocoa.csv file, right? So you probably have to just analyze that CSV file. So here you have company location. There's a column called company location. Oh, I'm not sharing my screen. Just a minute. So was this the question that you are asking? Somebody in the comments? Yeah, like somebody was just asking this. It says which of the following countries have maximum cocoa location? So yeah, I think all of these questions are based on, if you look at question number 5, there's a link to a CSV file. So in this CSV file, there's cocoa percent, company location, like many other columns are there. So you want to see which which country has most cocoa. manufacturing companies. So you have company and you have company location. So you can do a frequency table like we saw. So let me try to think. There are multiple ways you can go about this, but since we have, so either you can group by one column and try to summarize it based on, you can group by two columns and create a tally table, but we have not gone through that part yet. So based on what we've covered so far, you can try to compute this table, like this two-way cross tab. You can just try to use this. So if you use this, what will happen is that you use two columns, you use company as one variable and you use company location as another variable. If you use that, you'll have company and company location and the number. So you'll have France, maybe like 15 for company A. I don't know where is my thing? So you make company name. Let's say I'm naming it A, B, C. Like I don't know what else is here, but yeah, there's probably like A Morin, yeah, A Morin, A Cali, like yeah. So I'm just calling them A, B, C now. And company location, you'll have France, US, Canada. So you'll get some numbers. Probably you'll get something like this, right? You'll get different numbers. Yeah, from this you can just see which country has the most companies. You can look at it like that. So that's how you compare two variables. If you just wanted to compare how many, I don't know, these are beans origin. Or you can just try company location, you can do a value count. But that will, so by doing that, this variable is not taken into account. So I think the best way is to like look at this frequency table. You can try that. Yeah, I haven't gone through details of this Excel sheet. But yeah, when you have two variables, that's how you can do it. Maximum location. Yeah, I think that's what I meant in the question. Bean origin. So if you just do like company location dot value counts, it'll give you the count of all the beans, like bean origin, the multiple places. But it will not tell you the company. I'm not sure if this is the company place. Yeah, you can try that as well. You can just simply do like value counts for company location. You can look at that value. You can try computing a table and you can see like both of those together should make sense. You should be able to tell. Yeah, that's right. Yeah, I cannot discuss answers, but I can just hint that you can use this command. Like instead of cars, you use your data frame. Instead of automatic and fuel type, you should use the country name and the company name. Because the question is basically they've asked which country has most manufacturing companies. So yeah, you have to compare the company and the company location. So instead of these columns, you just replace it with that. I think I've sent a direct message to somebody. Let me just, yeah. Okay, yeah, I think we can come to an end to this lecture. Think we just have one more live session and probably like one more 1 hour session after that before your exam. If you have an exam, I'm not sure if you have an exam for this course. Yeah, the most important thing is that you just practice. And like if you don't understand any syntax, like especially like if you don't understand why you're getting an error or you don't know how to write a syntax, the only thing you can do is you Google it. Or yeah, the best one, another best way to learn is to use ChatGPT. But yeah, ChatGPT is not the best to apply in real world. Like when you're working in a company, you just get the code from ChatGPT and do it. Yeah, that will not work because it gives a lot of wrong commands. But yeah, you just have to be very specific about what questions you want to learn. So for learning, it's a very good source. But you can't totally rely on that because you need to like put in your knowledge as well. Because everything that these AI tools give, it's not 100% correct. So yeah, our jobs are safe. I could say that. Yeah, the key thing is to just practice. If you don't understand, you always have like resources. So, yeah, probably until like today, you might not have known how to make plots, how to visualize. So yeah, we hope like in case you didn't know, like you have got an introduction on how to look at files, how to make plots. So that was the main goal of the course, to just introduce you to all the functions that Python can do. So yeah. All right, if there's nothing else, I think we can just we uh we can end today's lecture. And I can see you next week, next Tuesday at 6 p.m. Yeah, I saw a lot of people, you have been joining the meeting, like even like this morning, last night. Yeah, like I'm not sure if you didn't know the time or yeah, it's every Tuesday for 6 to 8 p.m. All right then, see you next week. If you didn't know my channel details, the recordings will be uploaded. I'll just share the link to my last week's video. So yeah, you should be able to look at all the videos in that playlist. I think it's called NPTEL Python. Yeah, so you should find it in the channel. Yeah, so this is the link to last week's live recording, and this week's recording will be uploaded to that same channel as well. All right. Right. Thank you for attending. Yep. All right. See you then. See you next week.